Welcome back to the lecture series on heat transfer operation. This is Yogesh Landge. In today's lecture, we will see the topic. It is unsteady state conduction. In the previous lectures, we had learned the steady state heat conduction. What is steady state heat conduction? The Fourier's law of heat conduction, and with the help of the three geometry, we derive the various expression to know what is the heat transfer rate. There are the three uh, modes of heat transfer: conduction, convection, and radiation. We divide the conduction in two parts. The one is the steady state conduction and unsteady state conduction. In this lecture series, we look for the unsteady state conduction. The content from this one, in the unsteady state, we learn what is the lump parameter analysis, what is the Biot number, Fourier number, significance of the Biot number and Fourier number, heating of body with a negligible internal resistance, heat transfer to the semi-infinite wall. We will see the heating body under the negligible surface resistance, heating a body with finite surface and the internal resistance. So these are the content from this module 1, the topic unsteady state conduction. Let's see the first, what is the lump system analysis. When we call a lump system, the definition for the lump system analysis. So it is given that some of the bodies are observed to behave like a lump, whose interior temperature remains essentially uniform at all the times during the heat transfer process. The temperature of such a bodies can be taken to be a function of time only, and this idealization is known as the lump system analysis. Okay, so some of the bodies it is behave like there is a change only with respect to the time. With respect to the time, so in cases there is a body which it is behave like a lump, means there is a uniform temperature throughout the body, and such a body we call it is a lump body, lump system. Let's see, there are the two examples that we have taken here. One, it is small copper ball that we call it is a lump system analysis is applicable, and if you take the food content, that is a roasted chicken, in this case we call it is a lump system analysis is not applicable. Then why this copper ball it having the lump system analysis applicable, and why the roasted chicken doesn't have the lump system analysis is not applicable? Let's with the help of the examples we can see what exactly it is. So let's consider a copper ball. This is the copper ball. We show the temperature is 70 degrees Celsius. Okay, and throughout the body the temperature is 70. Wherever you count the temperature, you will find it is a 70 degrees Celsius. So this case we call it is a lump system is applicable. Why? With respect to the time, the temperature change, but with the space it is not changed. If you consider x direction, y direction, or z direction, or radial direction, there is a no change in temperature. It is uniform in the body. But the same case is not happen in the roasted chicken. If you take the another example of it, then here you found the temperatures are changed. So temperatures mentioned 40, 90 and 100. If you look at the temperature at the surface, when you put the roasted chicken into the oven, and when you are giving a heat to the roast chicken, the temperature at the surface you found it is a maximum one, means the temperature is around 110 degrees Celsius is mentioned, okay, in this example. And if you measure the temperature with the help of the measuring instrument, that is by using the thermocouple, then you find at the middle it is less than the surface temperature, means here it is found the 90. So surface temperature is at the surface the temperature is maximum, then at the middle temperature is less compared to the surface one, so it is 90. And if you put the temperature at the center, you will find it is only the 40. So if you look at the temperature internal temperature gradient between the center and the surface, it is large one. Okay, and such systems we call it, this system is not applicable, the lump system is not applicable here. Why? Because the temperature at the surface, temperature at the middle and temperature at the center are changed, but the same thing is not happen in the copper ball. Here the temperature at the surface, temperature at the middle or temperature at the center, wherever you measure the temperature, you will find the temperature is uniform, it is the same, only it is changed with respect to time. If you cool this copper ball and then slowly it goes down by way as the heat is transferred between the copper ball to the, say, to the surrounding, but the same thing is not happen here. When you put this the roasted chicken into the oven, you find there are the different temperature at the different layer, and such a system we are not call it is a lump system, and this is we call it is a lump system. Now take the another example from it. Let's we see the analogy. Understand the concept of the lump system analysis with the given example. So consider the analogy between the heat transfer to a solid passenger traffic to an island. So this is the one analogy of to understand the lump system analysis, what exactly it is. So this picture it shows the Iceland, and these are the buses in the Iceland for the transportation in the Iceland. This is the waters, the sea, okay, where the boats are the transport the people from the mainland to the Iceland. And on the harbor side, the buses pick up the passenger and transport to the Iceland. So in this case, what is the transportation? The people from the mainland it sit into the boat. The boat come near to the harbor side, and from the surface from the harbor the buses moves the passenger to the Iceland. So the same case, if you consider one copper ball, let's consider this is the copper ball, okay, that copper ball is put into the hot liquid, okay, the heat is transferred on the surface. Now in this case what happened, there are the two things. The one, if the number of buses is higher and the passengers are as per the numbers of the buses, then there is a no accumulation of the people on the surface. Means if the boat contains the 10 number of people come from the mainland, it reach to the Iceland, and it reach to the Iceland, and now the 10 number of people sit into the bus from the harbor line, from the harbor. Okay, now what happened here? 10 number of people come from the boat, 10 number of people sit, and this bus again goes to the particular the wherever these people want to go. Means there is no accumulation, none of the passenger are waiting for the bus at this point. Okay, so same thing is happened here. Again the 10 number of people comes, 10 number of people the people sit into the bus and reach to their destination. Okay, a similar way. So number of buses, number of boats, and the number of people, if it is equal, it means there is no chances of accumulation of the people on the harbor. But the reverse case, now such cases we call there is a continuous passenger comes and passenger goes. So smoothly the passenger move from the harbor to the Iceland. But if say the 20 number of people come from the boat and only the capacity of bus is 10 and only the one bus is here, it means the 20 passenger comes on the harbor, 10 passengers sit into the bus move into the Iceland of their destination, but 10 people are waiting for the bus. Now this bus went to the reach to their destination, then again comes to the harbor, and again they pick up the 10 number of passengers and go. It means for a certain time period, these 10 number of peoples are waiting for a bus, means they are accumulated on here. So if let's consider there are again 20 number of people comes here, then only the 10 goes and 20 again waiting for it. So in this case what happens, there is a not proper transportation in the Iceland, just because of the buses or the Iceland, it doesn't have that capacity to transport it. The same thing is happen with the lump system. What happened, if there is no accumulation of the heat on the surface, then we call it is a lump system. In the copper ball, what happened, the copper ball, the surface temperature say the 70 degrees Celsius of this fluid, as the conductivity of the copper ball is very high, so because of that, what the temperature at the surface is the same at the center, because there is a faster heat transfer between the copper ball. But the same thing is not happen in the chicken. In this case what happened, there is a accumulation of heat on the surface, because the conductivity of the chicken is less compared to the copper ball. Because of that, what happened, the heat is accumulated on the surface. That's why the surface temperature is higher, then the middle temperature is lower, and center temperature is very low. So this is the case. So accumulation of the heat on the surface, such a thing, such a body we are not call it is a lump system. But if there is a smooth conduction of the heat through the body, then we call it is the lump system. In the next lecture, we will learn the lump system analysis with the negligible internal resistance. Here we derive a derivation on lump system analysis. So in this lecture, we learn what is the lump system, what is the lump system analysis. Thank you.